When we talk of benefits of blockchain along with decentralization, many other aspects are spoken about like immutability of data, trustless relationships, peer-to-peer connectivity, data security, etc. But when we talk of issues that are a big hindrance to the mass adoption of blockchain by industry, what jumps out is scalability and nothing but scalability. The battle for a scalable solution is the blockchain's moon race. Bitcoin processes 4.6 transactions per second. Visa does around 1700 transactions per second on average. The potential for adoption is there, but is bottlenecked currently by scalability. From an architectural level, the unsolved problem of scalability is emerging as a bottleneck to blockchain adoption and practical applications. A study published by Tata Communications in 2018 showed that 44% of organizations in its survey are adopting blockchain, but also alludes to the universal problems that arises from deploying new technologies. And how bad is blockchain scalability today? In order to scale a blockchain, increasing the block size or decreasing the block time by reducing the hash complexity is not enough. With either method, the ability to scale reaches a ceiling before it can hit the transactions necessary to compete with businesses like Visa, which handles an average of 150 million transactions every day. By comparison, Bitcoin transaction speeds are tremendously lower. Currently, the block size is set 1 MB, and if used SegWit, then theoretical 4 MB takes approximately 10 minutes. And a block, given its size, can hold only 2,759 transactions. In other words, the Bitcoin blockchain can currently guarantee only 4.6 transactions per second. The problem of scalability comes packaged with blockchain value propositions. Therefore, one cannot simply increase scalability by changing parameters in the blockchain. The Bitcoin community can adjust two variables to attempt to increase the TPS. One variable is the block size or B, which is currently hard-coded at 1 MB. Ideally, B should be increased to increase TPS. The other variable is the block generation time or TB, which is adjusted by changing the complexity of the hashing puzzle. Ideally, TB should be reduced to increase TPS. But even making the above changes will not make Bitcoin anywhere close to the speeds achieved by likes of Visa, MasterCard, PayPals of the world. Let us look at some of the existing and future ways of solving the scalability issues in Bitcoin and then as an extension in blockchain. Before we get there, it is important to note that Bitcoin is a permissionless blockchain and issues related to them might not be present with permissioned blockchains. But the solutions that are being worked out might apply to any type of blockchain, though maybe with little differences. Let us start with SegWit, a short form for segregated witness. This allows the Bitcoin block size to be increased from 1 MB to 4 MB. It does so by segregating the witness part of each transaction from the actual transaction data. It occurred as a soft fork, so it was instituted without any major effects on the existing blockchain network and code. SegWit's soft fork has helped improve block size without changes to the core code, but it still does not improve the TPS in a scalable manner. Next is to batch payments into one transaction. The pros are, it reduces the size of the transaction record by putting multiple transactions into one, allowing for more transactions overall per block, which can increase TPS to an extent. The cons are, it cannot batch multiple wallets transactions together as that will risk privacy. Bitcoin Cash is another solution. The pros for this are, it can store more transactions than Bitcoin in one block, which increases capable TPS. The cons are, it is only a temporary solution as a TPS is still far below the 1700 global TPS that Visa conducts on average day. The solution is also limited to Bitcoin Cash, so it cannot be a solution for other blockchains. The Lightning Network. Pros are near instant transactions between parties with no fees. The cons: transacting occurs off-chain, requires users to have a Lightning node, and is limited to Bitcoin core-based blockchains like Bitcoin Cash, Litecoin, Digibyte, and Dogecoin. EOS and other high-performance blockchains is another example. The pros are high theoretical scalability, whereas the cons are centralization, which can lead to censorship. High-performance blockchain projects use different consensus mechanisms. One of the most popular alternatives to proof of work is proof of stake. A recent project, EOS, uses what it calls a delegated proof of stake or DPoS, which is a modified version of PoS. EOS used delegated PoS to claim up to 3,996 TPS, but the trade-off is centralization, which gives key stakeholders more power than the rest of the community. Though EOS is high-performing, the trade-off is censorship and centralization. BioXCloud is another example. The pros are, it is an on-chain solution and blockchain agnostic, so it can be an answer for scalability for potentially all type of blockchains. The cons are, it is still in development and building or operating a global content distribution network or CDN, in short, is an expensive feat that is yet to be accomplished in the blockchain space. You will recall from our session on scalability in Ethereum where we discussed scalability trilemma. That states that it is hard to achieve scalability, security, and decentralization at the same time. You will also recall that we discussed layer 1 and layer 2 solutions that are being worked out to address the scalability issue while maintaining the security and decentralization aspects of blockchain. With layer 1 solutions, we discussed methods like sharding, using different and faster consensus mechanism like proof of stake or delegated proof of stake instead of proof of work. Layer 2 solutions are aiming at moving a lot of work outside of blockchain, yet ensuring that decentralization and security aspects, including data immutability, is not compromised. Both layer 1 and layer 2 solutions are in works and may take some time before they are productionized. We have covered a lot of distance since we started this course. I'm sure you all have fair amount of understanding around what blockchain is, what are its components, what kind of different technologies combine to deliver the blockchain benefits, what are the types of blockchains, and of course some use cases. What is happening in the technology world around blockchain and how other businesses, domains, and industry at large is looking at the promises that blockchain brings about. The challenges around adoption, scalability, etc. I guess before we close this course, it is important for us to discuss and maybe summarize all of the above in a topic like roadmap to blockchain implementation. I have tried to depict the same in this diagram in a step-by-step manner. We start with analyzing the use case at hand. Ensure that blockchain makes sense to this use case and what kind of business challenges we are trying to address using blockchain. In other words, work out the return on investment or ROI in short. If blockchain makes sense, then figure out what type of blockchain and which protocol fits the best. Ensure that you carry out proof of concept before starting to think of development. Once proof of concept is done, you have your ROI and management is convinced it is time to plan the development. Define the minimum viable ecosystem or MVE in short and plan the entire development lifecycle along with project management lifecycle. Carry out development in iterative manner, short burst, preferably the agile way. While the development is on, start planning on scaling, expanding the MVE, production support and maintenance. Once the original system is in production, you should have the expanded MVE in place. Ensure all regulatory aspects, if any, are met. This includes internal audit requirements too. Plan for enhancements and upgrades in future. The entire above cycle is repeated for every enhancement and the upgrade, the new version. Well, are we suitably blockchained? This course should be able to generate keen interest in you all to learn more about this exciting technology and what revolution it is going to usher in the near future, and allow you all to get into advanced blockchain courses where you start learning the deep development methodologies and techniques to design and architect a blockchain solution.